All right, so we're going to go ahead and get started. Thank you all for being here. We'll go ahead and plug our next event real quick. That's going to be on November 7th, same time, same location. And that's going to be another local employer. That'll be Chris Salmons, who is representing Microbac, which is a company that works with various microorganisms and culturing and things related to that, quality testing and assurance and such. So that is again November 7th, same time, same location. You'll get email details and probably hear about it from your professors. Okay, and so without taking up any more of his time, I want to introduce all of you to Tom Gilmore. He is the technical manager at Evonik Industries in Etowah, Tennessee. That is a silica plant, which I will let him talk to you more about. He earned both his bachelor's and his master's in mechanical engineering from Mississippi State University. And a little bit about Evonik Industries. It's an international company, and while they're in over 15 states, in our country, they're in over 30 countries overall, so lots of opportunities. And while his plant does focus on silica, the company overall works with a wide range of materials. So whatever your interest may be, they likely have something you could get involved with. All right, I will turn it over to him.
All right. Hey, thanks for letting me come talk to y'all a little bit about us. I've got 77 slides to cover, so we're going to be here a while. No, I'm kidding. I've got 9, so we'll be quick. My goal is to let y'all talk. So I'm going to give a little bit of a pitch about Evonik, talk to us a little bit about that. And then from there, it's interactive. Y'all ask me stuff. I'm a dinosaur. I've been in this business for pushing 30 years. When I started out, we were still on drafting tables. CAD software was just cutting edge. I used the first Windows product. I remember when Windows 95 came out. So we used WordPerfect. We used Harvard Graphics. We used Lotus 1-2-3. So Bill Gates was still kind of in his garage playing and trying to figure out stuff. So I'm old, sorry. The flip side of that, though, I have been around. I've seen a lot of things. I've seen the leaps in technology. We have more computing power right here than what we had whenever I was at Mississippi State. I mean, it was phenomenal what these things can do. So anyway, with that, so here's a little bit about me. I'm with Evonik now. We got bought out in 2017. I started out with J.M. Huber up here. We're a silica manufacturing facility. So we'll get into what that is here in a little bit. The rest of my background, I work for Albemarle Corporation. Anybody who knows anything about the lithium industry, if you want to know about lithium, come talk to me. I work for Albemarle. We were on the cutting edge of the lithium stuff back in the mid-2000s, whenever it first started getting interest. International paper before that, have worked there for 13 years, learned in 13 years probably what it takes in most specialty chem businesses like I am now. 13 years at a paper mill is like 50 years anywhere else. Extremely fast paced, commodity basis. It's all about making production and getting tons out the door safely and within your environmental permits. So my mantra as an engineer and your mantra as being in the STEM fields, do it safely, do it environmentally correct, be that good neighbor, don't be that stinky chemical plant in the backyard of everybody. Nobody wants that. And do it morally and ethically correct. If you can't answer those 3 questions truthfully, back up and don't do it, or find another path. So as we talked about, mechanical engineer twice over. Why did I do it twice? Because whenever I graduated in 93, the job market was as jacked up as it is right now. You could not find jobs anywhere. So I decided, hey, I really liked mechanical engineering. I got to do some of the courses that I liked, but there's a lot of them I didn't get to take. So I went ahead, took an assistantship, taught, went into doing an internship there at State, got to take some really cool classes on stuff that's old school technology now. So we were doing all kinds of neat things with carbon graphite fiber and Kevlar and interwoven 3D geometry, metallurgy. So really cool stuff back in the day that we used to have to do all the calculations by hand. Now you throw it into MATLAB and it spits it out for you. So Other interests, my wife and I were very active in our children's church. I try to play golf. If you can't play, at least look like you can. Fake it till you make it. Try to catch a fish every once in a while. And then the big thing is our new grandson. So yeah, I'm not proud of him at all. I can't help it. So but he was born 14 weeks early and he's had a hard road to go, but he is walking, talking little miracle. So, and then the last thing down here, I've done all this stuff in the chemical industry and all that kind of craziness. I started out in aerospace. So I got the opportunity to work on a little fun jet that Honda built at Mississippi State. Honda built the prototype. That's it. Anybody who knows anything about aerospace, that is a weird looking bird because she's got forward swept wings, a high T-tail, and engines on nacelles, which are pretty, at that time, some of the three rarest type things to do in a jet. So, but we built it, flew it, almost crashed it multiple times. So fun things. So Evonik, if you've heard of us, congratulations, you're a rarity. We are a German-based company. Headquarters is in Hanau. So specialty based, we're owned by a consortium of bankers. It's been in business now, I think about 13, 14 years. It's a conglomeration of a bunch of other German chemical companies that all merged. We're in a little bit of everything, as you can see. Our products are over on the left. Pretty well anything that has chemistry involved in it. Automotive, food, electronics, environmental protection, food, livestock type things. Broad-based, wide portfolio for a company. Most of our products are specialty though, specialty versus commodity. So we're more like the mom and pop store on Court Square. So if you go down the main street up here in Maryville, I think it's Court Street, you go up there and you see the little mom and pop shops. That's kind of what specialty chemical is versus like a Walmart or a Target or a Lowe's. They're the big box. So commodity grade versus specialty chem. We're more in specialty chem. So somebody comes to us and they've got a problem and they say, hey, we'd like to do this. Can you all figure it out? We're a bunch of problem solvers. That's what we go do. So you take all of that and then there's 5 divisions. So the 5 divisions, specialty additives, all kind of funky stuff that they play with, nutrition and care, exactly what you would think. So lots and lots of makeup additives that go into makeup. We're huge into that. Pharmaceutical type things, it's nutrition and care. Smart materials is our division. I'll go more into that in a minute. Performance materials, that is everything from protective clothing fibers to automobile parts, you name it, it's there. And then the last is technology and infrastructure. So Evonik has an entire group of people, 34,000 total employees globally. Almost 1,000 of them are dedicated engineers that work in the technology and infrastructure group. So, and they're based all around the world. So primarily in Hanau, also regionally in the US, Mobile, Allentown, Pennsylvania, and Houston, Texas. So a little bit about that division. I'm not a part of that. I'm part of our process technology group because I work in a plant. And I clicked the wrong button. Let's see if it was advanced. Okay. So we went into the divisions. We talked about that. So within the divisions, there's all these other groups. Active oxygens or peroxides. So any different grades of hydrogen peroxide, you go to the store and you buy it in a little brown bottle, that's like 2%. We play with 70%, stuff that'll eat your skin off and make you feel like you're having a really bad day. Catalyst goes into typically the refining business. So where you're taking a barrel of crude oil and you're splitting it into all the different distillates that you want off that barrel. Coatings and adhesive resins, the C&A group, exactly what you would think. Coatings, paint. So we're into the paint business. So I know I'm old. You used to take a paint roller and you'd go up the wall with a paint roller and you'd have to go over it 3 or 4 times to get it to cover. You go buy some of the higher performance paints now, Behr, Sherwin-Williams, some of those things that are a little more pricey, you can take and go up the wall 1 time and it's a good thin uniform coat. It's because it's got our products in it. It makes it take and lay down really, really clean. High performance polymers, that part of the sector is foams. So one unique product that we make goes into submarines. So a submarine, whenever you're in the Navy and you're down under the water and you want to be very, very quiet, you drop a hammer inside the submarine and everybody hears you. Except they put a foam core in between the shells of the submarine from the internal to the external that's a super high density, super sound absorbing. So it deadens that sound so it can't permeate out into the water. So that's just one of them that we do in the polymer group. Silanes is a whole different division of silicas and polysilicas. It goes into wafers for chip production, all kinds of other fun, crazy stuff. My group is silicas down at the bottom, and we'll get a little bit more into what that is. So silica is one of the most fastest growing technologies in our plant, in our corporation. We're learning more and more about what we can do with silicas every day. It's naturally occurring, it's sand. So we take sand and we do stuff with it. So across the world, here's everywhere that we have a plant within the silica group. It's one of the 6 divisions, but it's one of the largest divisions, one of the fastest growing. We're building in this division, thankfully, all the time. We're looking to build a new plant in Charleston, South Carolina right now. So all of that said, what is it? 2 different ways to make it. All y'all that are in chemistry, y'all know a little bit about precipitation reactions. So we take sand, dissolve it in a caustic solution and cook it. So we call it dissolving, but we actually don't dissolve it. We'll make a colloidal suspension of it. So silica actually won't dissolve in caustic, but it will suspend itself in it. And it makes what we call water glass. So you can take a glass of hot silica, dump it across the table here, let it cool, and it makes a pane of glass. So it's really kind of cool. So we take that, then we run it into another set of reactors and we hit it with sulfuric acid. You take a acid and a base and you make a precipitant out of it. That's where we get our silica back out. So it makes a couple of byproducts. We recover the byproducts, but essentially that's what we do. So our plant is precipitated silica. We make our own water glass. A lot of the rest of the divisions or the plants around the world, they have somebody make it for us. We're a total, our site in Etowah is soup to nuts. We make everything from we bring the raw materials in, we make everything, and we ship finished goods out the back door. The magic happens, and I'll show you all that in a minute as far as what we do here, kind of what it looks like. I've got some microscopic pictures that'll show it better. The other way you can do it is they call it fumed silica. You actually burn it. So you take sand, oxyacetylene or natural gas torch, for lack of better words, put it in, you melt it that way, and then you recover it back out that way. So as it cools, it makes like a fly ash that is a pure silica, and then you recover that through filtration and bag houses and such, and you recover it. It makes very, very small, light, fluffy particles. So what do we start with? That is crystalline sand. That came out of a mine in Morristown, just up the road from us. It's a very high purity silica stream. It has very little lead content, very little aluminum content. It's primarily silica. We call it silica flour because it's a really lightweight, fluffy. If you grab a handful of it, like confectioner's sugar, it's thinner and fluffier than that. So I would bring it in here, but if you spill it, it goes everywhere. And the folks that are working in the cafeteria probably wouldn't like me too much. So, but the bad thing about this is you can see it's got little sharp, jagged edges everywhere. It also is a contributor to silicosis. So anytime we're working with raw sand, we're in respirators, we're taking care of ourselves, taking care of the employees, making sure they don't breathe this stuff and get it in their lungs. So what do we do with it? This is what it looks like after we do the magic. So we make 2 different types of silica. One's a low structure, one's a high structure. If anybody brushed their teeth this morning, you used that product, almost guaranteed. Our product goes in about 85% of all of the toothpaste made in the Americas. That is the abrasive in your toothpaste. So that's what's cleaning your teeth. So Evonik has about 85% of it in Americas, North and South America. Our plant in Etowah is almost 75% of it. So that is our bread and butter, is we make it regardless of the brand. Colgate, Crest, Aquafresh, Tom's of Maine, whomever you use my product. So thank you, keeping me in business. So the other side of it is what we call a high structure. Looks a little different, it's kind of fuzzy. That's the thickener. So that's what makes the paste paste. So our quality manager had the best analogy I've ever heard of how we make our product. Look at a golf ball. We start out with a golf ball that has no dimples in it. What we do is we take that golf ball and we make the dimples. So the number of dimples, the size of the dimples, and the depth of the dimples. That's what we do. So, and it's all based on the chemistry. It's all based on whatever we're doing the reaction step where we're precipitating it. How fast do you add the acid? How fast do you mix it? What temperature the acid is, what temperature the water is that you use to dilute, the temperature of your wash water. All of these different dynamics. So those of y'all, if y'all ever get to, whenever you get to fourth year chemical engineering and you start playing in kinetics and you start messing around with the reaction rates, that's the magic. And we know how to do it. Some people look at it and they say it's just pure magic. You know, how do you, we can predict, and we can predict it with a very high degree of accuracy what that's going to look like consistently. That's why everyone likes us. They know, all of our customers know that whenever they order that product, it's that product exactly. And the quality parameters, very, very tight box, but they know the repeatability of what we make. And that's why we've been where we've been for so long and have been successful. It's because we don't pinch. It's what we say we're going to do. We do it, we go do it and make it the way they want it every time. And I think that's it. So other things that silica goes in that we make, I talked about paint, talked about the dental stuff, spices. You go to Dollar Tree, because I know what it's like to be a broke college student, and you need some spices, and you go buy seasoning salt at Dollar Tree and you take and you put it on your food. And as soon as it hits moisture, you're sitting there and you're banging it on a table because it won't flow. So one of the end products of what we use is called a free flow agent. We put silica in spices. So if you go to the grocery store and you go to Publix or wherever and you get a Lowry's or a higher end spice and you pour it, and you can always pour it and it keeps coming out, those little dimples in that golf ball we made will absorb water. So it's a water scavenger. We can also make it to where it's an oil scavenger. We can make it to do any kind of moisture that we want. It'll reach out there and grab that moisture particle and lock it into the silica to protect the other stuff. Morton Salt is one of our customers. Salt, you don't want salt to clump up on you. A lot of people will put rice in their salt shaker so it'll absorb it. We put the silica in there. Everyone has seen the little pack of silica that says silica gel, do not eat in your food, beef jerky. We make the product that you can eat. Your body knows how to process it. It's all natural, will not hurt you. So the one that says do not eat, do not eat. But our stuff, you'll see it and you'll never know it when you eat it. So went through that kind of fast, but my goal was to give you all a chance to ask questions. So it's going to get real boring if you don't ask questions. What you want to know? Yes.
So I think that I gave up on myself, what do you do? I want to say that something quality that you expect.
So good question. So our first time right is 99.7% of the time. So out of all the volume we make, almost 100% of the time we're good. If it's not good, typically we can take and rework the product. So we'll take and recycle it based on whatever that it's out of spec on. We can run it back through the process and reclaim it. There's times if we can't, which is extremely rare, we wind up landfilling. But probably out of that 99.7% of the time, well over 95% of the time, we rework it, go right straight back through the process, and we fix whatever we messed up. Yes, ma'am.
You mentioned that there were byproducts that were found when you precipitated the silica. I was wondering what those byproducts were, and do you reuse them, or what do you do with them?
Okay, absolutely. So as part of the precipitation reaction, you're taking sulfuric acid and a caustic based silica that's a sodium with I'm not a chemical engineer or chemistry major, and I do not profess to be one. So it has it's a sodium with some silicas and some oxides and stuff attached to it on the end. Whenever you put that acid to that in that reactor, it makes sodium sulfate. That's what we wash out. So the sodium sulfate we don't really want. However, we've got a broker that's a company that loves it, and they use it for variety and sundry of products that go into food grade, goes into feeds, it goes into the roads. I know they use it in the asphalt industry. I don't know everything they use because it's proprietary, because they don't want us to know, because, hey, we'll take and sell it to your people. So we've got kind of a firewall between us and them, but we make it, they take it. But I do know a few things that goes in, but it's a sodium sulfate straight up Na2SO4. Do know a little chemistry. Yes, ma'am. Oh, go ahead.
Can you tell us a little bit about the environmental impact, if any, of the fumed silica?
I wish I could tell you more details. We don't make the fumed silica at our plant. We make it in Mobile, Alabama and Waterford, New York. I know that it's a very closed loop, tight process where we have a very, very high quality of no rejects. They have zero rejects. So everything they make, from what I could tell, probably the worst impact they would have is carbon dioxide from the heat that would be generated. But I know that in some of the plants, I don't know if we do it in the States, but they actually capture the carbon dioxide and they're using it through membrane technology and recovering some of it. So again, as we learn emerging type things, but the heat would be the release of the CO2 would be my biggest concern as far as what they do.
So what do you do for your day? Is it a lot of application costs?
That's one of those, it depends. So my role as the technical manager, what we're doing is we're more project engineering, a little bit of process engineering, and troubleshooting, problem solving. So we have a problem with one of our reactors. We have a small leak in it. Okay, what caused the leak? Did we do anything historically that's different in this reactor than we did the other one? We're going through trends of data. We've got our DCS system is capturing multiple streams of all the process variables. Okay, so did we add too much acid here and we got we put more acid in before we put water and we got a hot spot in the vessel? Those type things. So from the problem solving and the troubleshooting, that's kind of some of the things we do. Capital projects, which is one of the main things my team does. We're looking at, where can we spend money to increase the life of the asset? So new railroad. I just did a project, a $500,000 project to redo some of our railroads in the plant. Not real glamorous and exciting, but if we don't have railroad, we can't receive product or ship product. So got to have it. To fun, crazy stuff where we're looking at some membrane technology to do exactly what we were talking about with carbon dioxide capture. Some of the preliminary engineering and studies, how efficient can we be with that, with some of our waste streams and flue gases? And does that make sense from a financial aspect, or would that be better served? It's great technology, but is it good technology for us now, or is there someone else that would benefit more from it today and we delay ours 5 years? So those type of analysis are a lot of the things that we're doing day in, day out. My day, when I walk in, before I ever leave the house, I pull up my phone, I look and see, okay, whatever all happened last night, is there anything critical here that's not been addressed? And then I start going through the list and making sure we've got all of the prior nights issues, problems resolved, or at least got somebody working on it so that we can move forward and then continue working. So it's kind of, and some days it's the barn's burning down and we don't know what we're going to do in the next 30 minutes. And then some days it's very planned and scheduled and regimented. So it's kind of a generic answer, but it really depends.
Would it be fair to say that the entry level engineering STEM position would be a part of that team doing similar tasks at just
Absolutely.
responsibility level?
So we had an intern this year over the summer from Tennessee Tech, talented young individual, a chemical engineer. I threw him headlong in. I said, okay, what do you want to learn? And he wanted to learn some things about batch kinetics. How does that work? Because he was going into their senior level design course. And I said, sure, let's go. Let's go talk about addition rates and mixing rates and what all that looks like on different products. We use the same vessels and the same equipment. It depends on what the batch card is for what we're making. All of our processes are batch. So it's just like making a cake at home. You take the cake mix, the eggs, the oil, the milk, and you mix it together, and you mix it in certain, you want to make sure that you put the eggs in before you put it in the oven kind of thing. So you've got a sequence of how we do things. So that's what he wanted to learn, is why and how that works. So absolutely. So it really depends on what that individual wants to learn and how fast they want to learn. It's somewhat at your own pace because some people absorb things differently. My background, again, I know enough about chemistry to get myself in trouble. I know less about electrical stuff because I can really get myself in trouble there. Mechanical and structural and materials, that's my wheelhouse. I get excited when I get to talk about those things because that's what I know and I'm comfortable in that world. Flip side of STEM, though, you need to get uncomfortable every once in a while, learn some new stuff because, like I said, I'm a dinosaur. Yes, ma'am.
What's the difference between the silica gel packets and the silica that you put in seasonings?
It's a lot of it's the way it's made. So we are a food grade plant. Everything, because our end product is going into consumer goods, everything we do, we make silica that is food grade. By being quote unquote food grade, there is a very strict regimen of design criteria, quality criteria, production criteria that is regulated by a group called the British Retail Consortium, BRC. BRC manages everything called GMP, which is good manufacturing practices, which everyone has to, if you're making food grade products, you have to be certified by a body. There's 8 different bodies. We use the BRC and GMP. So all of our products to be certified for food has to be made to these standards. So we're an ISO 90,001 plant or 9001. We're an ISO 14,000 plant. If you don't know what ISO is, ISO regulates, you say you're going to do these things and they come in and tell you, yes, you're doing those things well, or you're not doing those things well. So multiple regulatory bodies and agencies ensure that we are doing what we're supposed to do to make food grade. The little other packs, they don't do it that way. So that's the difference. And it's a whole lot cheaper.
Skills do you look for in the intern, and then what do you think?
So people have asked me a lot, what do I look for when I look at a resume? Career fairs, we go to career fairs. I've probably got 2 minutes max to look at your resume and usually interacting with an individual career fair. The intangible things is really what I go after. You've gone to a school that's an ABET accredited college. I trust that they're teaching you the technical skills. I'm going to look at if you've done an internship or a co-op, those are always pluses. I know a lot of people don't like internships and co-ops because it delays your graduation. The knowledge of your craft that you're going into, though, is worth every minute of that. The other things I look for are where have you proven yourself as a leader? And that could be a crew lead at McDonald's. I made an engineering student furious at me one day in an interview because they had all this great stuff that they had done as an intern at Dow and DuPont and NASA and whoever else they had worked for. But I picked up on their resume. I said, what did you do when you worked as a crew lead at McDonald's? Because a lot of what we do in STEM is we're customer service. Somebody has a problem, somebody has something they need help with, we're customer service. You can be the smartest, most brilliant engineer in the world, but if you can't communicate, you're useless. I'm sorry, you are, because you can't sell your product. You can't sell what you've got up here. So when I'm talking to someone, I'm looking to see, do they have good eye contact? Can they communicate? Can they talk? What have they done as far as leadership and that servant leader? how do they interact with people? Because I learn a lot more talking to my operators at the plant than I do other engineers. Those operators are out there touching, feeling, smelling every day. Where the engineer, I may walk through a part of the plant once a month. But those operators out there every day, 12 hours a day. So they know what's going on. They may not be able to exactly tell me in a technical basis of what's going on in the process, but they know when it doesn't feel right, sound right, smell right. Those are, I know it's kind of a roundabout, but I really look more for the soft skills, because the technical side, like I said, you went to an ABET school. ABET's American Board of Engineering, American Board of Engineering Technologies, I think. It's the accreditation board for all engineering schools. So just like what I was talking about with the BRC and GMP, they say that your engineering school is teaching a good curriculum. So if you went to an ABET school, I know you got a good education. Your soft skills are the piece, that's a lot of the pieces I can't teach you. You've already got that. Now, some of it I can help you with time management. I can help you with, certain skills, the drive and the want to, and the gut side of it. There's not a lot I can help you with. You've already got that. Okay.
A question about the future of the company, if you're able to maybe speak that at all. I know chip manufacturing, as far as like handsets, phones, is coming to the US fast and furious. Do you see any role in Evonik and Silica kind of doing research or in that field? Or?
So one of the largest growing, I know more about silica than I do a lot of the other parts of the business. One of the largest growth markets for us within silica right now is in tires. So you'll see some of the commercials with Michelin and BF Goodrich. They're talking about green tire technology, where the tires that last longer, they're more fuel efficient. All of those things is because they add silica to the tires. The silica acts to extend the life of the tire. It also decreases the rolling resistance of the tire while increasing the grip of the tires. Silica's sand. It's abrasive, so it helps you get grip on the road, but it doesn't wear out as fast. So we've built a very large facility in Charleston, South Carolina in 2017, and we're about to almost double its capacity right now again. So that is a growth market for us. The dental industry, unfortunately, is a very stable industry. There's most everybody in the Americas brush their teeth. So we have to go other places in the world to look for oral care opportunities. So the silica, that part of the silica business, not so much, but the other part of that is it's a very stable business. As far as overall, Evonik as a corporation, very solid because we're so diverse. If you ever look at a business and you're going to work for somebody and they don't have a very diverse background or portfolio, as y'all saw, I started my career in the paper industry. Everybody thought the paper industry was dead. I mean, the paper industry is dying. I was in printing and communication papers. So we made copy paper, 2,000 tons a day at the paper mill in Selma, Alabama. I worked 6,000 tons of trees, 300 truckloads of trees a day is what we went through. So that part of the paper industry is dying, but the other part of the paper industry, which is brown boxes, is exploding because of the .com industry. Everybody gets on Amazon or whomever, and they get it shipped to their door in a brown paper box. So that part of the paper industry is doing well. So look at the diversity of your company that you're going to go to work for and see what that diverse portfolio looks like, because that will tell you the health of your business. So thankfully, Evonik is a very diverse company that has extensive background and portfolio globally.
And I know you say you're into tires, so is it just consumer tires, or do you something that's in that commercial tire, because they don't want it to last as long in that section, so like you do some silica there?
Most everything that we're doing, when you start looking at performance tires, like exactly what you're talking about motorsports, they don't put the silica in because you want that extra bite and traction, so you're willing to sacrifice the longevity of the tire for the performance side. So not as much there, but consumer tires, tractor trailer tires, those type things where you're wanting to get extra mileage out of it, that's really where our slice of the business segment is. Yes,
So
ma'am.
you talked about leadership. You talked about, shift manager at McDonald's or something like that. Lots of our students are involved in leadership here on campus. For example, you're captain of the basketball team.
Sure.
Or you're, I know, I happen to look over, the captain of the basketball team happens to be in the room right now.
Okay.
But just other things like, oh, I led this club, or I did, are those things that they should place on their resume in
Absolutely,
terms of that?
absolutely. Now, I will tell you, if you were the Rotarian third grade student of the month for May, in third grade, I'm not so interested in that, because that's been a few days down the road. Absolutely, any kind of student government leadership, captain of the basketball team, residential life floor advisor. I don't know if I call them RA still or not. So, but those type things where you're in a position where you're having to make decisions, you're leading, you're guiding, you're giving wisdom. Those things are important, because that's what we're looking for.
So, let's say you do have a lot of those soft skills, but you're still lacking on the technical skills that you also, let's say, you want to go to, you still take that.
Sure. And we understand, you don't know it all. I used to make students very mad. I would tell them, so when I was with International Paper, we hired 10 engineers a year, every summer. Brand new engineers, straight out of the box, Georgia Tech, thought they knew everything. I'm sorry, there's nobody more arrogant in the world than a Georgia Tech engineering grad. Been around the block too long. Come in there, I'm a Georgia Tech mechanical engineer. I would walk in there and I would tell them on day one, you went to school at a great university, your education starts today. And they would get mad. Sorry, you've learned, we're going to teach you how to apply what you've learned. And that's another thing, if you're the STEM side, I know I'm going a lot in engineering. STEM side of the world, chemistry. Chemistry is more of the theoretical side. It's maybe not as much of the applied side, whereas the engineering is the applied side of it. The chemistry side is what helps us, because the chemistry is what teaches us how to learn. And then we take what is learned on the chemistry side and then do it to the applied side so we can make a product. So the chemistry absolutely is where everything starts. So the skills, we can help you learn those skills. Project management, I've been to, I don't know how many different project management schools with 3 different corporations. I can teach you how to do it inside out, upside down. And I don't expect you to know how to do that because you've never been exposed to it. So but you have the basic skills that the colleges have taught you as far as how to think, how to learn, how to dig and find information. Trust me, with y'all with engineering tips and Google now, y'all way outpace what I did back in the stacks at the library digging through periodicals back in the day. So you have the world at your fingertips, literally, with these things that we didn't have. We can teach you all the rest of it. So even if you don't think, try, apply and try, see what happens.
That's one question. How many interns do y'all take?
So unfortunately, we haven't taken many, usually 1 a year is what we're able to take. I would love to have more, but we usually try to take 1 a year at our site. Now, globally within Evonik, there are a couple of different intern plans. So if you go evonik.com/jobs, and I should have put that up there, but there is a job board out there where they will start looking for interns. They have an internship program for graduates that is a global rotation program. So you'll do a US internship, you'll do an internship overseas, and then you'll do a third US internship, and then you get to kind of pick, okay, where do I want to go to work? They also have an internship for college students, and all of that it's not managed at the plant level, it's managed at the corporate level. At the plant level, we try to get creative and reach out to a college somewhere and say, okay, can we pick somebody from somewhere and come in and let them have a partnership? Because it's both of us. I want y'all to learn something out of it. I want a product out of it, but I want you to learn something from it too that you can apply and move forward. Are we doing on time, Brett?
We're good on time. Do we have any final questions?
Well, let's think our speaker.
Well, I got one more thing I want to challenge you with. So like I told you, I'm a dinosaur, I'm an antique, I'm ancient. Whenever I walked in, I was in the band at Mississippi State, played sousaphone, too. Band, 360 students, what have you. Our band director told us, day one as a freshman, he said, look to the person to the left and the person to the right. He said, only one of the three of you will graduate. He said, that's the graduation rate at Mississippi State at that time, and I don't think it's much different anywhere else. The other piece of it, in the STEM side, it's 1 in 10. 1 in 10 students that started STEM will finish STEM. Don't give up. Keep digging. Keep digging at it. Don't let it kick your tail. I know it's not fun when all your friends are going out and they're partying all over the place, and you're sitting there studying polar matrices and Cal 3. It stinks. It ain't fun. You know, doing second order differential equations at 3 in. That ain't fun.
But it is though. Those are my favorite classes.
Sorry, it's not
Okay.
fun. But it's the foundation. You've got to know the foundation of why all this stuff works. As being the scientist of the world and doing the STEM, we're the people that folks look to help solve problems. And that's a trust that degree confers upon to you, that people trust you, that you're going to use that degree and you're going to use all of this that's up here to help. So don't give up. Keep digging. It ain't fun, but keep digging. It gets fun. You get to go play with stuff that you never got to play with before. I've gotten to do some really cool stuff in 30 years that I would have never thought I would have gotten to do. So, and ask. The reason I'm an engineer, the ASVAB told me I should be an engineer. I didn't know what an engineer was. So, but ASVAB told me, so that's why I went in engineering. So, but just keep digging. And if you got questions, ask. Brett's got my contact information. If you want to know something, shoot me an email. I'll do my best to answer it. And if I don't know, I'll tell you, I don't know. And that's an acceptable answer. There's a lot of stuff day to day that I don't know, but we'll try to find an answer. So, and y'all do the same thing. Well, good. Thank you.
No, thank you. I'll be sure to send out a link to the website you mentioned, the Evonik/jobs, so you guys can access that. I'll also send you a link to the YouTube video for this in case you guys want to check any of it out later. Please give our speaker a big round of applause.
Thank y'all.